My name is Alperan. I'm a second-year PhD student at University of Maryland, College Park. And for this year, I was the chair of the programming contest for ICFP'22. And I am here to present you with the programming contest report. So let's start with our beloved logo. I like it a lot. And then move on to some general information. So some people may be unfamiliar with the ICFP contest. The contest has been running since 1998, so this year was the 25th. And every year, a different organizer picks it up, and there are unique questions, unique problems that are that are left to that year's organizer. So it's very unique in that sense. So I would like to thank some people that have helped me throughout this organization. They are my friends from undergrad, so Emre, Eren, and Ozan. And I would like to also thank Jasper, last year's organizer, and Andre for their help throughout the process. So let's go to the interesting part, right? Let's start talking about the problem. The problem had three versions of the specification. The first one is the first 24 hours, the second one is the second, and the third one is the third. So in the initial problem, we start with a target painting. You are supposed to somehow do something with it. And you are given an initial canvas. And you are supposed to actually paint the canvas into the target painting. And I will come to that. I will come to how you do that in a second. In the second type, now you don't have an empty canvas anymore. You are given some initially colored blocks. And you can use these blocks to your advantage, or they can be to your disadvantage if you don't use them. And in the third version, now you are given another painting as your initial canvas, and you can use that to color your target painting. So we are talking about coloring. What is this? How do we do it, right? There are a set of operations and a set of instructions that are provided for the participants. And the first one is the point cut. You pick a point somewhere on the canvas, and you cut it to four rectangles from that point. And the second one is the line cut, which could be either horizontal or vertical. And there are small details there with the block IDs and numbering, but they're not really important. Third one is coloring. You take a block and you color it with some RGBA code that you give. And we have merge, where you are able to merge these small blocks into one larger block. And the last one is the swap operation, where you can, if you have two blocks of the same shape, then you can swap them. And so you are doing these operations, right, and trying to paint this picture, but we must judge you somehow. So how do we do that? We have some cost function that operates on these colors, canvases, and all that stuff. So the first type of cost function is the color cost. When you have some block, when you have some canvas, let's say that this is your initial canvas, right? And your target painting is all gray. Then the color difference is we use this RGBA Euclidean distance to get the color distance of these two pixels, and then we aggregate them over the whole painting. And if you had something farther away with respect to RGBA space, then you would have a larger cost. And the second type of cost is the instruction cost. Each instruction has an associated cost with it, and that cost is inverse proportional to the size of the block. So the participants, you'll see, yeah, when the block is larger, the cost is lower. So the participants must resist the urge to do exact paintings. They must stay at some level of blocking so that the solution doesn't exponentially grow. And let's go into our tasks. We have a lot of tasks. We have 40 tasks. Each of them have an initial canvas and some painting. And you can see all of them here at the screen. We have the chessboard, the Tetris, the view of the Haskell programmer, a bunch of mosaics. They are the initial canvases from the second type of question. And we have a bunch of Mona Lisas, like the real one, the simple one, the one of my friends drew. Yeah. And let me show you some examples. This is the first question. And I like this a lot because it is what sparked the notion, the idea. This was the first example that I came up with when I was designing the question. And this is another one. You can see that you can use the colors on the left to your advantage. Unfortunately, almost none of the teams did that. They just merged it and they acted like the initial canvas didn't exist. I was sad about that, but what can you do? And yeah. The funny thing is, the left one is actually a class project. We had a image processing language. So one of my friends actually wrote that by hand. And let's go to the solutions. The solutions are yes. So you can see that some of them are exact, like the chessboard, the robot painter. Lambda is similar, but when you come to the girl with the Earl earring or Mona Lisa, you can see that it spoils a lot. Yeah, and you can see the differences. These are the best submissions, by the way. This is the highest scoring submission. And this one, yeah, I like this one a lot. This is Curves. Godfather, yeah. And this, Inception, the round thingy. And yeah, I like this one a lot too. Yeah. So moving on. So what did the participants do, right? Because they had to work a lot during the 72 hours. They had a lot of different approaches. We had, I'll come to the statistics in a second. We had a lot of people working on the tasks, but I will give some of them here. We had the greedy approaches. That's the easiest thing to do. A lot of teams did dynamic programming. All of the canvases were 400 to 400, so it was possible to formulate the problem as a dynamic programming problem if you did some optimizations. Some teams did integer programming, and I like the last two a lot, because I thought of them, but I don't think anybody would actually write them. So the people optimizations is because you are doing these automated solvers, they are sometimes generating unnecessary instruction sequences. So some teams identified these things and they went a second, they did a second pass over the instruction sequence and they deleted those. And there is also the target image manipulations. So instead of going from start to the end, from the initial canvas to the target, they started manipulating the target, and that sometimes made things easier. And there are a lot of teams that did manual solving. They wrote CAT tools, basically, and they used those to solve the questions. And some statistics. We had more than 300 teams registered, more than 150 teams submitted solutions, and almost 100 teams submitting solutions to all 40 questions. The entry barrier was relatively low because even though you could submit an empty query, you would get some result. But so I think teams like that because they could just start doing something by doing nothing. Yeah. And some impressions we got. Yes, the problem specification was great. It was a really fun contest. It had a number of bugs and glitches. We had 3 bugs. We had to rejudge everything. It was a bit bad, but people didn't complain much. He enjoyed this year's contest. While the specification was short and sweet, it did have some frustrating ambiguities. Yeah. And a couple of technical issues. Yes. And yeah, what the participants have been waiting for nearly 10 days, the prizes. And the first prize is the judges prize. It is given by the judges, me, at our discretion based on some vague factor. And I have chosen the cat is #1 team, which they are an extremely cool bunch of hackers. I went over all these submitted solutions, and they had great visualizations, and they had a great README. So thank you for that. And the second one is the winner of the Lightning division. I didn't go into that. The first 24 hours is just it has a special price, because the teams that do something there, they should be pretty fast. And our GB team was pretty fast in that. They have a write-up. It's a great write-up, I think. And you can see that they applied some local optimizations that they thought they start with a simple solution, and they did a lot of local optimizations on that. So that made them instead of generating something from start that would be a bit heavyweight, it made them faster. So great job, guys. And Rust, C++, and Python are very suitable for rapid prototyping. Yes. Our third prize goes to PGML. They use C++, Rust, and Python, and those languages are not too shabby, you know. And they were at the 8th place when the scoreboard froze 2 hours before the final, before the contest ended, and they advanced to the 3rd place in that amount of time. Great job. Our second prize also goes to the RGB team. Yes. What can you say? And our first prize goes to the Unagi team, which they use Rust for the solver and Go and Python for all of the utilities. And apparently those languages are the programming tool choice for discriminating hackers. And I believe that they were also winners of the last year. So yes. So